Integration of trigonometric functions. Whenever a function f dash of x is recognized as the derivative of a function f of x, then the differentiation of f of x with respect to x equals to f dash of x if and only if when the integral of f dash of x with respect to x equals to f of x plus the arbitrary constant. So the differentiation is true if and only if the integration is true. Similarly, the integration is true if and only if when the differentiation is true. So referring to the derivatives of trigonometric functions derived earlier in the differentiation tutorial, we see that the differentiation of sin x with respect to x equals to cos x if and only if the integral of cos x with respect to x equals to sin x plus the arbitrary constant. But the differentiation of cos x equals to negative sin x if and only if the integral of sin x with respect to x equals to negative cos x plus the arbitrary constant. Then the differentiation of tan x with respect to x equals to sec square x if and only if the integral of sec square x with respect to x equals to tan x plus the arbitrary constant. The differentiation of sec x with respect to x equals to sec x dot tan x if and only if the integral of sec x dot tan x with respect to x equals to sec x plus the arbitrary constant. The differentiation of cosec x with respect to x equals to negative cosec x dot cot x if and only if the integral of cosec x dot cot x with respect to x equals to negative cosec x plus the arbitrary constant. The differentiation of cot x with respect to x equals to negative cosec square x if and only if the integral of cosec square x with respect to x equals to negative cot x plus the arbitrary constant. So all these integrals should not be considered as 6 facts to be memorized, but the knowledge of the differentiation is more than sufficient to keep the integrals in mind. It can be shown by considering the corresponding differentiatives that the integral of a constant times cos x with respect to x equals to the constant times sin x plus the arbitrary constant. Also the integral of cos bracket ax plus b with respect to x equals to 1 over a sin bracket ax plus b plus the arbitrary constant. So here we are getting a coefficient of 1 over a because once the integral of cos is found, the terms inside the brackets are differentiated and it is divided by the result. With similar results for the remaining trigonometric integrals, integral of 3 sec square x with respect to x equals to 3 tan x plus k. Then the integral of sine 4 theta with respect to theta equals to negative 1 over 4 cos 4 theta plus the arbitrary constant. So the integral of sine is negative cos. So with that, differentiating the terms inside the cos and dividing by the result. Then the integral of cosec square bracket 2x plus 3 pi by 4 with respect to x equals to negative 1 half cot 2x plus 3 pi by 4 plus the arbitrary constant. Here the integral of cosec square is negative cot, and whatever you get inside the brackets, you differentiate them with respect to x and you divide the result by the differentiated terms. Integral of cosec phi theta dot cot phi theta with respect to theta equals to negative 1 over 5 cosec phi theta plus the arbitrary constant. So the integral of cosec phi theta dot cot phi theta is cosec phi theta, and also by integrating the terms inside with respect to theta we get 5. So the whole result is divided by 5. Then the integral of sec pi by 2 take away 6x dot tan pi by 2 take away 6x with respect to x equals to negative 1 over 6 sec pi by 2 take away 6x plus the arbitrary constant. So the integral of sec x dot tan x is negative sec x. So using that we got negative sec pi by 2 take away 6x. When we differentiate the terms inside the bracket with respect to x, we get negative 6, and when the result is divided by negative 6, we get negative 1 over 6 sec pi by 2 take away 6x plus the arbitrary constant. Now take a couple of minutes and try out these questions by yourself. Integrate the following expression with respect to x. Integral of 3 cos bracket 4x plus pi by 2 with respect to x. So the integral of cos is negative sine. So we get negative 3 sine bracket 4x plus pi by 2, and when the terms inside the brackets are differentiated with respect to x, we get 4. the result is divided by 4 with an arbitrary constant. Next we have the integral of 2 cosec 3x dot cot 3x with respect to x. So the integral of cosec x dot cot x with respect to x equals to negative cosec x. So we get negative 2 cosec x, which is cosec 3x, and differentiating the terms inside the cosec we get 3, and dividing the result by 3 with an arbitrary constant.